Welcome to another Algebra 2 lesson. Skill 21 is all about solving polynomial equations using synthetic division. So last class we solved polynomial equations by factoring and setting the factors equal to 0. All the solutions we arrived at were nice solutions that were integers or rational numbers. In this lesson, you will solve polynomial equations that could involve irrational solutions. So I want to remind us of how to do something like that. Let's start with an example like x to the fourth minus 81 equals 0. This is a difference of squares because I could take the square root of each of those. So I'm going to write this as x squared plus 9, x squared minus 9. Okay? Now x squared minus 9 can break down into x minus 3 and x plus 3. However, the other factor, remember this is not a difference of squares, so I can't factor it. Okay, so now we have our three factors, and we set each one equal to 0. Now these two are pretty easy to see what the zeros are. Whoops, that's supposed to say negative 3, and there we go. So we have those two. What about this one? Well, for this one, to take x squared plus 9, to find it, we're going to set this equal to 0. Subtract 9 from both sides, so x squared equals negative 9. Take the square root of both sides, and we got a negative number under the square root, so we have to break that down as square root of negative 1 times square root of 3. Well, sorry, I don't know why I wrote 3, I meant 9. So, square root of negative 1, we call that I, and 9 can be broken down into 3 times 3. So we'd say x equals plus or minus 3i. Okay, so we have that 3 that would come out of the radical. There's no leftovers to keep inside. And then also remember when you take the square root, you're doing a plus or a minus. So we would interpret this as x equals 3i, x equals negative 3i. So our solutions to this equation are these two that I already came up with, and then these two that we just saw. Okay? So that's what it means when you could have irrational and or complex solutions. Okay, so I didn't put complex here, but could also be complex. Okay? Alright, so let's look at example 2. On this example, we're going to solve a polynomial. This one, if you look at it right now, you can see that we don't have a technique yet for how to solve something like this because there's 5 terms. No, actually there's 6 terms, so I can't do grouping. And I don't have a GCF in all terms, so I can't whittle it down that way. But we are told, fortunately, that we have a factor of x minus 1/2. Okay, so since we're told that information, we can start by using synthetic division. Okay, so this is what we learned a couple lessons ago. So what we do is we take that factor, find its 0. So the 0 of that factor would be 1/2. So we're going to put that in the corner. And we're going to look at these coefficients and we're going to check 2 things. One, to see if it's in standard form. So all exponents going from highest down to the lowest. And then we're also going to make sure we have all terms accounted for. So we have a 5 and then a 4 and a 3 and a 2 and a 1 and a constant. So we're good to go. All of our terms are there. So we're going to go ahead and write our coefficients down. Okay? Now the way that synthetic division works is you bring down the first term and write that down. And then you're going to take that 4 and multiply it by 1/2. So 1/2 of 4 is 2, positive 2. Negative 2 plus 2 is 0. 1/2 of nothing is still nothing. So remember I took 0 times 1/2, and I put that number here. 2 plus 0 is 2. 2 times a half gives me 1. Negative 1 plus 1 is 0. 0 times a half is 0. And negative 30 times a half, half of negative 30 is negative 15. So we have a remainder of 0. So this polynomial ends up being 4x to the 4th plus 2x squared minus 30. Now I know you might be thinking, why didn't you write the things with the zeros? Well, that's because those terms, when we look at this polynomial, those will just confuse us. This is now a 3-term polynomial, and when we solve this, well, I notice all terms can be divided by 2. So let's go ahead and take care of that first. So that's going to give me 2x to the 4th plus x squared minus 15. Okay? And now we can factor this using our ACB tree. Alright, so for my ACB tree, a times c is going to be negative 30. B is a positive 1. So we're looking for two numbers that multiply to negative 30 and add to 1. Since they multiply to a negative, I need a negative number and a positive number being multiplied. And since we have a positive sum, I need more positive than I did negative. So I'm going to have negative 5 and positive 6. So I'll rewrite this as 2x to the 4th minus 5x squared plus 6x squared minus 15. Okay, and then we just factor by grouping. Okay. And in the first group, I could factor out x squared. And so we're there. In the next group, I can divide these by 3. Sorry, I should have showed what I was doing here. And when I divide those by 3, I get 2x squared minus 5. So my factors are x squared plus 3, 2x squared minus 5. And of course, we don't want to forget that x minus 1/2, we don't want to forget that that was also a factor. So I'm going to bring that down as well. And we're going to find our zeros. Let me change color. This is a little light. So x squared plus 3 equals 0. 2x squared minus 5 equals 0. And x minus 1/2 equals 0. First one, I'm going to subtract 3 from both sides. And then I'm going to take the square root. I've got an imaginary number here, so I'm going to have plus or minus I radical 3. So think of that as I radical 3 and negative I radical 3. Next one, I'm going to add 5 to both sides. Divide by 2. So I get x squared equals 5 over 2. And then I take the square root, and I'm going to have x equals plus or minus radical 5 over 2. So we could think of that as radical 5 over 2 and negative radical 5 over 2. Okay? So I've got 1, 2, 3, 4 solutions so far. In this last one, if I add a half to both sides, I get x equals 1/2. There's my fifth solution. Okay? So remember, we have a degree 5 polynomial, so we know this is a degree of 5. So we should have 5 zeros. 1, 2, 3, 4, 5. Okay? Let's try this next one. On this next one, I can see that I have another factor given to me. So x minus 1/3 is the factor. So the 0 is positive 1/3. That goes in the box. Let's see, I have an x to the 5th, x to the 4th, x to the 3rd, x to the 2nd, x, constant. Everything's accounted for, so I'm just going to go ahead and write my coefficients. And here we go. All right. So looking at what we have now, we're going to bring down this 3. 3 times a third. When you're multiplying by a third, another way to do this is divide by 3. Okay? So 3 divided by 3 is going to be 1. 0 times a third, or divided by 3, is 0. Negative 3 times a third is negative 1. And then we get 0. And then we get negative 30. Okay, so this gives us 3x to the 4th minus 3x squared minus 90. Okay, remember this becomes x to the 4th. But I don't need to write my 0 terms in there. Okay, so we're going to factor this in the same manner that we did before. I could divide everything by 3. So I'm going to get x to the 4th minus x squared minus 30. Okay, so we go to our ACB tree. AC is going to be 1 times negative 30. So negative 30. But we need our two numbers to add to negative 1. So once again, I'm going to use the numbers 5 and 6, but this time I need negative 6 and positive 5. Okay? So I'm going to rewrite this polynomial. I'll do this up here. I'm going to write this as x to the 4th minus 6x squared plus 5x squared minus 30. I'm going to factor by grouping. First group, I can divide these by x squared. That gives me x squared minus 6. Second group, I could divide those by 5. And I get x squared minus 6. So my factors are x squared minus 6, x squared plus 5, and of course don't forget the factor they told us. Oops. So x minus 1/3. Alright, so x squared minus 6 equals 0, so we get x squared equals 6, so x equals plus or minus radical 6. Next one, we'll have x squared equals negative 5, so x equals plus or minus I radical 5, because we're taking the square root of a negative. And this last one, we're going to have x equals 1/3. Okay? Now, if you were to write this list out separately, so if I wrote this out, the plus or minus radical 6 means radical 6, negative radical 6. These mean I radical 5 and negative I radical 5. And then the last one is 1/3. Okay? Alright, last example. This time we're told the factor is x plus 1, so we're going to put negative 1 in the box because that's the 0 of that factor. This needs to be rewritten, so my x to the 4th is my first term, then minus x to the 3rd, then plus x squared minus 3x minus 6. Okay? Now I had to rearrange those to get it in standard form. Now I'm going to write my coefficients. Okay? Bring down our first one. 1 times negative 1 is negative 1. Negative 2 times negative 1 is positive 2. 3 times negative 1 is negative 3. And negative 6 times negative 1 is positive 6. Okay? Since we have a remainder of 0, that's good. I can now write this. So we had x to the 4th, so now this will be x to the 3rd, x to the 2nd, x, constant. So let's see, x to the 3rd minus 2x squared plus 3x minus 6. That looks like I can factor by grouping. So I'm going to group the first two and the last two. First group, I could divide by x squared. Oops, I didn't mean to put that inside. And we'd have x minus 2 left over. Next group, I could divide by 3. So we end up with x minus 2 and x squared plus 3. And let's not forget about our original factor. this one, x equals 2. This one's easy, x equals -1. This one I have to write as x squared equals -3. Take the square root, and I get x equals plus or minus I radical 3. Okay, so my answers are 2, -1, I radical 3, and -I radical 3. Alright, I know there wasn't any U tries on here, but if you just wrote down every example here, you should be able to do the assignment okay. That's all you have to do, just what we modeled here.